First of all, welcome everyone. I'm Rachel Dickler. I'll be the technology facilitator for this session. So please let me know if you have any questions or difficulties. You can put them in the chat. This is the Using the Learning Sciences and Computational Approaches to Develop Assessments and Intelligent Tutoring Systems session, which is an expertise connection session. So it's specifically designed for leaders in the Circles community with expertise on a topic to first share information and examples with participants who want to learn more about the topic, but also to provide a forum for participants to discuss how they might incorporate the topic into their own work. And then third, to really broker connections between community members around a topic. So as you go through the session, I hope you get a chance to learn and think about what you might be able to take to the strategy sessions that will be happening tomorrow. And that's where we're going to start to make some plans for how we can remake broadening. And so in this session, we'll have 3 presenters. All 3 presenters are going to be focused on the same 3 questions. First, how do computer scientists use AI methods such as, but not limited to, natural language processing and machine learning and data mining techniques? And then how do learning scientists use theory to create psychologically valid ways to understand learning within technological systems? And then third, what additional pieces and perspectives do we need to ensure that equity is considered in the development of AI systems? And then as time allows, we're going to be considering how different stakeholders such as learners, families, educators, and researchers can all work together in the design of these systems. And so there will be time after the presentations for an open discussion, and we'll encourage you all to ask questions and share your ideas aloud or via the chat. But also for now, just make sure to add your name, your current position and affiliation to get the conversation started. And with that, I'm going to hand it over to our first presenter, Janice, who can share her screen and tell you about her current work.
Hi, Rachel. Thank you so much. Hopefully this is the right slide. Okay. Perfect. Well, thank you so much, everybody, for coming. I'm really happy to be here. Thanks, Rachel, for the introduction. So I'm a professor of learning sciences at Rutgers Grad School of Education, and my work sits at the intersection of learning sciences and computer science. And I'm also the founder and CEO of Apprentice, which is an ed tech company that uses AI to do real-time assessment and instruction of science inquiry. So our student platform is called INKITS, and it addresses the problem that students perform poorly in STEM. For example, American students are currently ranked 18th internationally. So today I'd like to kind of use the system as a use case to exemplify and describe how AI techniques are used for science inquiry assessment and scaffolding in particular in my system. And then how we used theory to create psychologically valid ways to understand science inquiry learning, and then talk a little bit about equity and fairness as well. Starting here with INKITS, we have simulations that students engage in inquiry. They do authentic experiments with virtual simulations, and here students form a hypothesis. They collect data with their simulation to address their hypothesis. They interpret their data, they warrant their claims with data, they communicate their findings in words in claim evidence reasoning format, etc. As students are doing inquiry with simulations, there are affordances of authenticity because the simulation is like the thing it represents, and these offer greater validity than multiple choice tests. There's logging, which generates rich, high fidelity data, and these are used for performance assessment, and work products and inquiry processes are used for assessment. It can give immediate feedback and blends learning and assessment in that regard. And machine learning is needed for ill-defined problems like inquiry because it can handle the 4 V's, what are called the 4 V's: volume, veracity, velocity, and variability in students' log files, in particular in science inquiry, because it is an ill-defined problem space. So all activities in INKITS were designed using evidence-centered design, the literature on students' difficulties in science inquiry, and multiple iterations with teachers and students using doing think aloud protocols. So students also get real-time personalized support from a virtual tutor named Rex. And research shows that this helps students learn and transfer skills both to new topics and over long periods of time, tested up to 180 days. Teachers get real-time reports on the left that eliminate subjective and time-intensive grading. Machine learned algorithms auto score students' work, and this greatly reduces teachers' grading time of labs and matches human scoring with up to 95% accuracy. Natural language processing algorithms are used to score students' writing and compare what they do with what they write, because we've shown that between 30 to 60% of students are misassessed at science inquiry if teachers rely on what students write as their means to assess them. So for example, we have false positives. That's where some students have shallow knowledge of science, but can parrot back what they've read or heard. Or we have false negatives, where some students can do science, they can go through the processes of experimenting, interpreting data, etc., but they're less skilled at describing what they know in words. Teachers also get actionable alerts shown on the right, identifying which students are struggling and how to help them with tips. Tips are teacher inquiry practice supports. So you'll see this on the next page. We have a deeper example here. Here's an example of the dashboard. We call this ink blotter. And you see at the top, you have John Marcone is having trouble with hypothesizing. The teacher can click on this link and it says John Marcone is struggling to understand what an independent variable is. The teacher can see how he's doing on various other inquiry practices and gets contextual information about the day. The teacher could also switch to the class view and get a sense of a very accurate read, in fact, on how many students are struggling with a particular inquiry practice. For example, if students are interpreting the wrong variables under data interpretation, she could see that, or he could see that 80% of their class are having trouble. They can stop the class in real time and do real-time instruction. So teachers use this dashboard for inquiry instruction in real time. And our recent research shows that more students can get help and get it sooner versus no alerts. And Mike Salpedro did that work with Rachel. Students improve on the practice on which they were helped, as shown on their next INKITS lab, and that's work shown by Rachel and others. And there's a new paper in the Journal of Learning Analytics on that. And furthermore, students helped by a teacher using these alerts, the ink blotter system, improved at a significantly greater rate than a matched cohort of students who did not receive help. Furthermore, Rachel's paper in JLA shows that epistemic network analysis led to showing that the help that teachers gave leads to student improvement and is not focused on content, rather is focused on the practice. So if teachers give help on the content, that's not what's important with vis-a-vis leading to the transfer. What's important is when teachers focus on the practice. This makes a lot of sense, because if the teacher is helping the student with the practice, the student can then use that information or that competency to work on the next inquiry activity. So we use AI methods, including data mining techniques. So for example, we collect data with a simulation, we build our text replay clips, we tag these clips for skills, we define the features using RapidMiner, and then we build and validate the detectors. Our detectors, or our assessment algorithms, we use those terms synonymously, are validated using a held out test set across very diverse student samples in order to mitigate against bias. So this system provides pedagogical support to teachers and to students, and it can deliver reliable and equitable resources to students, teachers, parents, and other stakeholders, because the activities are guided by evidence-centered design and the literature on inquiry learning. The activities and subcomponents underlying the inquiry practices are iteratively refined via user testing with students and teachers. The data mined algorithms with students are built and validated using log data collected with diverse students, and generalizability is tested with new students who were not used to build the algorithms. So in terms of implications for assessment in ITSs of science, this approach can inform the design of future scalable assessments for science inquiry skills or practices. And this is important to stakeholders seeking rigorous performance assessment. Data mining can assess and scaffold students' learning process is in real time at scale, and both will help realize the promise for NGSS. So thank you so much for your attention, and see inkits.com for more data, information, papers, etc. Thank you.
Great, thank you so much, Janice. A virtual applause to you. And I'm going to hand it over now to Diane. So Janice, if you're able to stop sharing, and I'll have Diane share her screen.
Okay, thank you. And my talk is going to be focused on the same broad set of issues, but particularly from a natural language processing perspective, which is my area of expertise in artificial intelligence. So I first wanted to sort of frame the two terms that we were asked to talk about. So assessments can be both formative and summative, and I know Aditi has a lot of information explaining more on this distinction, and particularly formative, so I won't say much about that, but just to say that my work is also largely in the formative space. But I did want to talk a little about when I use the term intelligent tutoring systems. I think this is a good example of broadening in this context, that I think many of us think of a tutor as somebody who's an expert, like an adult tutoring a child. But there are also a lot of interesting ways that one can build computational systems where the so-called computer tutor can play different roles. For example, the tutor could be a student peer, or the tutor itself could be the student, letting the student take the role of the teacher in a kind of teachable agent paradigm. So I'd like to start first by just giving some concrete examples of some of the systems I've built over the years that use natural language processing to address interesting educational questions. All of this work is typically interdisciplinary, done with people from psychology department or school of education. So as I said, most of my work in assessment is informative assessment. A lot of it is in the area of writing, ranging from elementary school to college level students. And for example, this system is a automatic essay scoring and writing evaluation system where students are asked to read a text. They then have to construct an argument saying whether they agree with the author of the text, their claim, and then support their opinion based on citing evidence from the text. So they type in an essay, we then analyze it, and by our analysis, we give it a score according to a rubric, but we're not so much interested in showing them the score, but more why we came up with the score, and that's the basis of formative assessment, guides their revision. As Janice said, that one big advantage of this approach is very scalable. It's a real-time interactive system, and it can free the teachers up for other things, or to kind of give more nuanced feedback than what the system and NLP technology can currently support. Another project, that project was focused on elementary school, and a project focused on high school and college, were more explicitly focused on the revision process itself. So that system only considers the analysis of one draft. In this system, we input 2 drafts. And this is something most people don't really explicitly have time to teach, but understanding the process of revision has shown to be extremely important in developing writing skills. So we use natural language processing to compare the 2 drafts, kind of like a track changes, but at a much higher level, where the changes are tracked, for example, in how the argument changed. So did the student add a claim or add more, change their evidence? And not only what they did, but do we think that these changes are going to actually improve the quality? And so in this system, we don't so much give the student feedback, and it's more in a self-regulation framework where we display this information to the student, and they actively need to sort of process it and to maybe do additional revisions based on that. And turning from these kind of longer essay documents, another area we've looked at are very short kind of natural language free text. This is an application where it's designed for large lecture classes where students are asked to reflect after the class. So they type in these short comments, kind of like what you see in social media. And as they're doing that, we're trying to assess the quality of their reflections with respect to their depth of thinking and scaffold them as they're typing this to think more deeply, because that's been shown to increase content learning. Finally, the last project I think I'm talking about with respect to assessment is assessment of conversational data from classrooms. And this system is trying to assess the quality of the classroom discussion with respect to argumentation, how well the students are making claims, supporting their claims with evidence, and building on each other's ideas. And so again, natural language processing takes the transcripts from speech, tries to analyze them and display useful analytics. This screenshots are aimed at helping teachers. Turning towards tutoring, as I said, there are different ways that you can view the system. The current project that I'm currently working on in this area with various colleagues at University of Pittsburgh, including Aaron Walker, who's one of the people on the Circles group. We're doing work with a social robot, and the idea is students can learn math by our target audience are middle school students, and the idea is they learn math by teaching the robot. And so this builds on spoken dialogue kind of technology. Okay, so with those examples, I'd now like to briefly address the three questions that we were asked to talk about. So the first was, how do you use AI to build these systems? So from my perspective, I view kind of three basic roles where NLP is very useful. So one is, if the thing that you're trying to access is inherently linguistic, obviously that knowledge will be good for guiding the assessment. So for example, in our work on essay scoring, a lot of the ways that we can analyze writing, particularly low level things like grammar, that obviously builds on syntactic knowledge, but even the higher level discourse structure builds on different types of linguistic knowledge. And for this, we're building on natural language processing techniques and argument mining, which tries to take a text and figure out its underlying global structure in terms of argumentative concepts, like, is there a claim, is there evidence, how is the evidence connected to the claim, and figuring out which pieces of the text correspond to those labels. This area that I talked about with robots, that builds on the area of spoken dialogue systems, kind of what you see when you interact with like Alexa and Siri, but some extra interesting things because it's embodied. So you not only have the verbal communication, but you have nonverbal aspects as well, such as gestures. Oops, sorry. And the third area where I think it's useful, so the first was talking about processing, where the content knowledge to be learned is related to language. The second is using language as the teaching mechanism, so conversation as the instructional method. And the third is just, there are a lot of artifacts that happen during educational scenarios, often involving free text, and can we use NLP for that? So in this reflection app, not only do we process them and assess them with respect to helping students create deeper reflections, we also, because it's aimed at very large classes, use NLP summarization techniques to take, for example, in a class of 200, 100 comments and digest it down just to a few so they can get the gist of what they said without having to read it all. Okay, so the second question was turning to kind of the learning sciences. So my work is, as I said, very interdisciplinary. I usually start with real problems from these educational domains in collaboration with my colleagues. Where I think the answer to this question, at least in my work, comes in is how we frame the problem is really based on theory. So exactly what sort of constructs we actually want to do, how we're going to use them, that's all drawn from this interdisciplinary perspective. And then with these theory kind of motivating our design, we then build the technology, keeping these constraints in mind to build our systems, which you can then deploy with the target audience and evaluate them, and then the cycle continues. And finally, the last thing we were asked to talk about was what is needed with respect to equity. So as we heard just in the keynote, AI systems are often used for decision-making and can potentially lead to really bad decisions with horrible consequences if the systems are biased. And sort of the role of algorithm bias in NLP has been an area of increasing interest that really has just taken off in the last few years. So for example, some examples of where we've been looking for bias in automated essay scoring project is if the algorithm scores students of a different demographic group, even though it has no idea what their group is, if, for example, the error rate for female students is different than the error rate for male students, or if it's always underscoring one group versus overscoring another, and the groups that people have looked at are what you might expect: gender, race, socioeconomic status. There's a call to think about that more broadly, about different ways that your algorithms might perform differently. Another example is even if the algorithm performs well, it's reflecting inequities that are in a data set. So society is biased, and if you just look at text and learn things from existing text, you're probably going to learn things you'd rather not. And so sort of recognizing that happens and trying to mitigate it when it does is another way that we can consider that. And I've highlighted some approaches that people are taking. They kind of span the whole phase of a data science approach. First, the data that you collect should be sort of more consciously thought about with respect to this perspective. Often people collect data from convenience samples, which are typically skewed to whoever's around rather than being representative. And if you have a lot of data from one group and not from others, it's likely your algorithm is not going to work as well for the less represented groups. Even though once you try to monitor for that, sometimes the algorithms still will have problems. And there are a lot of fairness evaluation measures that are being developed these days to help you quantify once you've developed your algorithm, even on a nicely distributed corpus, are there still problems? And using those when there are problems, there are people working on algorithmic approaches to mitigate that. So for example, in essay scoring, it might be some of the features, even if you're not using like gender to make your prediction, there might be features correlated with gender. If you remove that from your model and replace it with less biased features, you might still be able to get the same accuracy without the additional bias. So working on, once you detect it, using those techniques. And I guess I will stop there.
Great. Thank you so much, Diane. Another virtual applause. And just as a reminder to everyone, we'll have time at the end for open discussion with all of the presenters. We have just one more presenter coming up. And with that, I'll pass it over to Aditi if you'd like to start sharing your screen.
Can you see my screen? Okay. So I would like to introduce myself first. So I'm Aditi Mallowarpu. I'm a very recently joined postdoctoral researcher at Digital Promise, and I'm also a visiting scholar at University of Pittsburgh. I have worked at New York Hall of Sciences. That's the project that I'll be talking about today. And I'm a recent graduate from UIC, which is University of Illinois at Chicago. So varied affiliations from back and forth in my life. So I'll be talking today about one example of how we can use computational techniques or data mining specifically to generate formative feedback for specific open-ended learning environments. So the open-ended learning environments that I will be speaking about today is a museum exhibit. So to start off, this is Connected Worlds, and it is it's a digital large-scale museum exhibit. It's a simulation of an ecological system that is currently installed at the New York Hall of Sciences. It can accommodate up to 40 visitors at a time. The system has 4 plantable biomes. This is the desert, the plains, the jungle, and the wetlands, and 3 sources of water: the mountain valley, the reservoir, and the waterfall. And the visitors have to interact with the exhibit by diverting water from the water sources into the plantable biomes where they can plant seeds. So the goal for the visitors here is to actually maintain diversity and to sustain it for a very long time. So they can plant seeds by raising hands in front of the biomes to sow seeds. If there is enough water present, the seeds sprout into plants and attract many birds and animals. And the task of creating diversity and sustaining it becomes difficult because the group has to continuously disrupt and interrupt the natural process and also conduct their social interactions with each other and with the exhibit at the same time. And the exhibit was specifically designed to teach the visitors to the concepts of sustainability and diversity, and to show them that every decision that they make and every action that they take can have very different experiences, just to get them speaking about or thinking about concepts like climate change or any other complex systems topics. So the open-endedness in connected worlds specifically comes from its ability because it can accommodate multiple evolving goals. Because as connected worlds, the visitors interact with connected worlds, the environment changes and evolves, and the system changes its state. So the visitors also have to evolve their goals and actions according to their context. Secondly, there are multiple people, so there are multiple goals and multiple actions happening at the same time. And because there are the visitors need to continuously manage the system, there is no correct or incorrect answers. We specifically cannot provide the visitors any pre-tests or post-tests to ask them to understand how much they got or how much they did not. So we cannot term any answers or solutions or their strategies to be correct or incorrect. And these kinds of exploration-based learnings in open-ended learning environments have been deemed to be very useful when we are engaging visitors and learners to difficult and new topics. But the same open-endedness requires that the learners keep track of a lot of information, because you can see they're constantly distilling and filtering from what they have already explored and what they can do next. So they often need to understand what the current context is and identify what the current complex properties are in the environment that they are looking at, and also to make decisions and to take actions for an informed inquiry process. And the traditional formative feedback definition does not help much. The traditional informs the learner according to the gap between what they have done and what they should be doing. But when it comes to open-ended learning environments where there are many solutions and many goals and many strategies, it is very difficult to come up with a small set of what they should be doing. So, and the functions that this formative feedback delivers are very solution centric. So it has one set solution or a small set of solutions which are termed as correct or incorrect. And the learners' actions and the solutions are compared to this one to tell them how different they are, or how different their actions are, or what they can do to correct their actions or fix their solutions. So to correct this solution-centric and learner-centric formative feedback to accommodate multiple goals, we reconceptualized what formative feedback can actually mean. So for open-ended learning environments that actually support explorations, we redefined it to be more problem space centric rather than learner centric. And what that means is it should be able to tell the visitors or the learners what they can do next. So help them connect the dots between the actions that they are taking and the effects that they are seeing in the system, and help them explain how did they get here by helping them join the dots of different cause-effect relationships that exist in these complex system environments or the concepts that they are learning, and also to help them explore the possibilities in this space. So if they know what are the other possible things that people have explored, or what are the other strategies people have done, that can be provided as a formative feedback for them to guide their exploration process. And to do this, we conceived a computational method, which is a complete data-driven pipeline. So starting from the log files, which are collected from the interaction of the visitors of ranging from all ages, right, from 2 to 60. We collected interaction log files and we included all the age ranges because we wanted to see how the system responds to this collective interaction with the exhibit, because the exhibit does not really differentiate between small groups and big groups. It can accommodate a very large group in total. And based on the tasks that they are allowed to do in the space and the kinds of responses that the system gives out, we built a causal model. So a causal model is a machine learning technique which can actually learn patterns from the visitor log files. So in this case, specifically, we are trying to learn the temporal lags, which are very important for complex systems, and also the cause-effect relationship, so that we can provide a possible exploration map for the learners to know what are the possibilities. And the outputs from the causal modeling gives us the causal chains, which actually help us build up the exploration map to show them what is the possibility. But to every group that comes into connected worlds, because every group will have a very unique experience depending upon the decisions they make and the actions that they take, we have to make the feedback that we provide them contextual, otherwise it can be very overwhelming. So what we do is we pattern match the causal chains that we mined out in the previous step to the current context of what the learners are actually seeing. And the filtered out patterns then are given to them as formative feedback to answer the 3 questions that we saw earlier. To do this, in order to help resolve issues of how different stakeholders would be seeing, this feedback or using this feedback, we employed a very human-centric approach to understand the different perspectives of the people. So when building the causal model, we involved the visitors and the facilitator, who is the museum docent on the floor of the museum exhibit, who is assigned there to help the visitors answer questions or help them interact with the exhibit. So we consulted them very closely in building the causal model, including what they needed to understand and the kinds of questions that they get from the visitors when they are on the museum floor. And after we got the contextual chains, we again went back to the experts, the content experts who were involved in creating the exhibit, to understand whether the complex systems content or the complex system properties that people are looking out for, that they want to actually convey to the visitors, are they still holding out into the causal chains that we have mined out. And we also spoke to pedagogical experts to understand the pedagogical value in portraying such feedback in the manner that the facilitators would like to use and pedagogically will be helpful. And to do this, this whole involving the stakeholders, for us, it took a very participatory approach, where we had participatory design sessions with the facilitators and the experts. And for the visitors, we had in situ sessions with the use of the dashboards, where we wanted to actually see how they responded to it and understand their comments on what they think about such formative feedback. So the whole project was based on the fact that the many stakeholders came together to help us understand how data mining methods can be put together to help the different stakeholders. In our case, it required a very hands-on approach with all the stakeholders and understanding their perspectives. I would want to invite everybody to join us in conversations about how what are the other ways that we would like to do that. Thank you.
Thank you so much, Aditi. That was amazing to hear all of these ideas, but from you, from our other presenters, Janice and Diane. And what we can do now is open up the floor for questions as well as contributions, thinking about some of the questions posed by our presenters. If you'd like to share, you can unmute, or you're welcome to also use the chat, and I can relay your ideas and questions as well.
Everyone's very quiet.
Well, I can start us with just a question, thinking about some of the challenges encountered. And I'm just curious from all of your perspectives, what you encountered, as well as what you foresee as major challenges now, having gone through the pandemic and remote learning, and what that's really introduced, new things that we have to keep in mind, both from the learning sciences side and the computer science side, as we continue to develop these tools.
I can start off to answer Rachel's question. So I think it has definitely been a challenge, especially when you're trying to accommodate stakeholders who are elsewhere, because I live in Chicago, the museum's in New York, and it's been closed for an year and a half. So obviously we're not going to see any visitors for some time now. And it's a challenge. So it has been a upward hill where we had to find new ways to engage the stakeholders, and having to simplify these black box data mining methods, because when you talk about causal modeling, it's a very complex inference method. It's not easy to explain it to visitors or facilitators who don't have expertise. So really helping them, giving them cue cards and things like that, which help them, give them an equal footing, has helped in my case. Yeah.
Right, just to build on that, for us, we typically need to go like in person with the students for much of our data. Obviously, that was difficult. On the flip side, even though Zoom is kind of horrible in its many ways, from a technical perspective, it does have nice advantages. So recording like data in a classroom is extremely difficult. You know, it's sort of infeasible to give like mics to every student. And so all the speech is kind of muddled. It's very hard to, you know, get clean speech from a speaker. With Zoom, you get that for free. And so for a processing perspective, it's really nice, but obviously we all want to go back in person, but it would be nice if, I think for people who have had to use it and found sort of the niche for that type of thing, those do provide, I think, new technical opportunities that maybe we haven't seen before.
I'll just add, we collected a lot of data during COVID, and it was really interesting to see how creative teachers got with respect to how they would use Zoom and put kids in breakout rooms, or some teachers would set out individual breakout rooms for each student, so he or she could just quickly whip them into a breakout room. And it was really interesting to see how teachers were very creative with using our dashboard alongside students using Inkits from home. And we got some very nice data, and actually data that showed that some students that were in, quite disadvantaged situations in ELL, with ELLs, large proportion of ELLs, did better at home with our software than they did in the class with our software. And, we wondered about why that was, and maybe they're not distracted by their peers, but it was really quite interesting to see that, there were many, many classes in which students did better than they had during the entire year. So we're looking at that a little bit more closely, but, I think what's interesting about COVID is that many teachers who hadn't embraced technology have really had to learn how to do it, how to use technology for learning. And they've been really impressed by, their own learning curve and how well it's actually worked. I mean, it's not ideal. Let's be clear. It's not ideal for a number of reasons, but I think that teachers have been really responsive, and many of them have been very surprised by their students' learning and their own ability to kind of take this technology on in our case.
Great. Thank you all so much. Yeah, it's definitely interesting to think about that balance, right? The give and take, that it's forced us to think differently, but still the challenge is there. And we do have a question in the chat that I'll relay, which is there merit to using commercial adaptive platforms?
I guess I'll take that since I'm going to interpret ours in that vein because we are productizing this under the company label of apprentice. So I suppose that, when schools are paying for it, I mean, first of all, software should work regardless of whether schools are paying for it or not. But when schools are paying for it and you're hoping for that renewal, it really has to work. It has to scale. It has to work. And what happened with us is that when COVID hit, the U.S. Department of Education asked us to give it away for free to any schools who wanted to use it, which we did. And we really made our infrastructure much more robust and scalable. And that was kind of they say, what is it? Necessity is the mother of all invention. And we've done well in this context. Many schools who bought us as a virtual option are now hybrid this year and renewed, or they're back in the classroom and they liked it, so they've renewed. And so we're fairly optimistic. So I think the benefit, in short answer, the benefit to a commercializable product is that, it's not that you're guaranteed more more stability from the infrastructure, but I think that if you're a commercializable business, you absolutely need something that's going to be highly, highly reliable.
Aditi or Diane, did you have any?
I guess I'll just say in the field of natural language processing, there are definitely a lot of, well, maybe not a lot, but there definitely are some number of commercial platforms, particularly in this area of writing evaluation. It's kind of a traditional thing for places like ETS, and the pandemic, again, going back to that, has been somewhat disruptive because universities now are getting rid of those requirements for like TOEFL and things like that. So it's kind of both changing the commercial landscape, that they're now focusing on more formative scenarios than the summative ones that they traditionally focused on. And then, of course, there are places like Duolingo, which is, a commercial, well, it's commercial, but it's free. And they're really sort of gearing up in this space and building quite a larger research group to kind of address the underlying learning sciences issues as they're sort of filling the niche that the traditional testing companies are now having to sort of share that space.
Well, thank you. Yeah, do we have another question? Go ahead. Yeah.
Hi, I have a question about like bias, because some of you mentioned about removing biases from assessment. So I agree that bias should be removed, of course, but sometimes, for example, like a variable like gender correlate with a variable that is actually crucial to assessment. So how would you treat those biases or variables? What's the ethical way of treating those variables?
So I'm not exactly sure I understand the question. What do you mean that it's crucial to assessment?
So let me come up with an example. So for example, suppose a student are writing an essay, and for example, verbal men tend to, for example, I don't know if this is true, but suppose men tend to support their argument less likely with external resource. So that is actually crucial to argument writing. But that's a bias based on the gender, right?
Right. So I think you're bringing up an important distinction, like at least in writing evaluation, you want your algorithm to have construct validity so that it's sort of using what you're supposed to be using. And so if whatever you were just saying about a particular way of using evidence, if that's actually what you're trying to measure, and you're having a distinction, then yes, that's something that's going to be much more difficult to fix. Then, for example, if you happen to notice that one gender, their essays are a lot longer, and if you're using that, for example, as a predictor, and that's really not what you're trying to measure, it happens to work well, but it's just kind of a artifact, then that's an easier one to move. So yeah, it's not, I mean, sometimes when you realize there's a problem, it's not always obvious how to fix it. And I think that's a good point, but sometimes it is obvious. And so you can make some headway.
Can I also just add to that about bias and the advantage to machine learning over knowledge engineered systems of assessment, for example. So knowledge engineered systems typically use an expert model to compare as the canonical model of what a student might do. And this is problematic because in ill-defined problems, there's many ways in which students could do something correctly or incorrectly, like in the case of science experimentation, science inquiry. So with something like math problem solving, you can use knowledge engineered rules because there's very typical incorrect answers. There's there's one correct answer, like 2 + 3 is always going to equal 5, for example. So machine learning has an advantage over knowledge engineering because knowledge engineering can have like an expert blind spot, and it's very difficult for experts to imagine all the ways in which a student is going to do something in a buggy way. So machine learning has a real advantage in that sense.
And it looks like we do have another question in the chat as well for our presenters. Natural language analyzers can be expensive. Are there any open source ones or low cost ones that you know of? Avtar was interested in using it for student feedback to instructors.
Yes, I can briefly comment. I'm not sure like what is meant by natural language analyzers, but there are a lot of open source or free kind of software for sort of toolkits to build a natural language program. So it's not necessarily like an end product, but given a text, it will let you do various things with it. And, they're pretty straightforward to use. So for example, Berkeley and Stanford, their NLP groups have those available. And there's a natural language toolkit is a sort of Python infrastructure with a lot of stuff you can kind of use pretty easily on your own data sets. And then of course, if you have better computing power, there's a lot of neural deep learning kind of approaches and software that is sort of a shared infrastructure for the community.
Now, I was wondering if there was something easy to use because we're interested in looking at the feedback which students give to instructors at the end of the semester. And I did use some free sentiment analysis program that gave me 40% negative sentiment for my teaching evaluations. So I don't want to use it anymore. But I was wondering whether there were similar programs which could be easily used, not necessarily turnkey ones, which are totally interactive, but with some knowledge of computing and AI, if people can set that up and do a project like that, or see what the sentiment is from the student feedback.
Yeah, I mean, I guess easy is relative, but if you are comfortable like with machine learning approaches and you can kind of combine, open source or, again, toolkits like that are available for traditional machine learning, and then use the NLP tools to kind of construct the predictors. And those, I mean, are more complicated than just taking a sentiment tool off the shelf. But as you're finding out, just using things off the shelf, if your data is not very similar to what they were designed for, it's not going to work well. So often one is required to either kind of fine tune existing things or, basically kind of use the software, but retrain it on your own data, because educational data is not kind of the thing that NLP people use as their mainstream. So I mean, for me as an NLP researcher, it's very good research area because you can't just often use the existing algorithms. They need some tweaking to kind of respect the constraints of the learning sciences.
Thank you.
Great. And we may have time for just one more question if anyone had a quick question to pose. Janice?
I'm just curious where the various audience members are from. You know, are you practitioners? Are you researchers? People can turn their camera on. We can just do a quick show of hands. How many people are practitioners? I don't know if it's quick to set up a poll if people don't want to turn their cameras on.
I don't know whether if you call me a practitioner, but what we are using is adaptive learning for flipped classes.
Okay.
Because what we found out was that the biggest challenge in flipped classes was the pre-class learning. So the
Was the
adaptive
what? Sorry, what'd you say?
the biggest challenge in flipped classes was the pre-class learning. What they come to the class having already learned.
Oh, their prior knowledge?
Yeah, not just the prior knowledge, but the prior practice they need to do.
Oh, I see.
Flipped classes, because in flipped classes, you are doing lots of active learning within the classroom, so it doesn't leave a whole lot of room for lecturing. So we are using adaptive platforms. That's why I was asking about commercial adaptive platforms, because the kind of things which I'm hearing here, they are so advanced. These commercial adaptive platforms, we're using Realize It out of Dublin, Ireland, and it serves our purpose because the students are coming much better prepared now, because it if somebody is very good at some kind of prerequisite material, they can breeze through it. Others struggle through it, and they just are able to pace themselves. So we're using it for a class as part of our NSF grant.
What did you call it?
It's called Realize It. I'll put it in the chat because it's a strange name to name. It's Realize It. Yeah.
Oh, huh.
Yeah.
Interesting.
Yeah, I used to use Smart Sparrow, but then that got, I think, got bought out by some other company, but they're not allowing, I think, open, there's not an open license for it, not open source license, but individuals cannot use it. Only you can use it through Wiley books now. So I had to jump to Realize It after using Smart Sparrow for several years.
I see.
Yeah.
And you work in industry, or where do you work?
No, I work at the University of South Florida. So I've been teaching,
okay.
I teach this course called Numerical Methods, and I thought it was very conducive to using
Okay.
adaptive platforms. So it's math related. So,
Oh, interesting. Okay.
Yes, and scrolling through the chat as well, it looks like people had posted that we have a number of graduate students, including PhD students, also present, which is great, and some other researchers as well.
Oh, great. So no teachers.
Not that anyone has posted.
I see. Okay, interesting.
So yeah, with that, we are towards the end of our session. I do want to leave time for everyone to make their way over. They rescheduled the welcome and announcement sessions to start at 5 p.m. Eastern time or at 2 p.m. Pacific time. So we hope you're able to join for that. You'll just have to go back to swap card. You can go through the agenda, and then it should let you in right at the start of the session. And then our sessions will resume again tomorrow, starting at 10 a.m. Pacific time or 1 p.m. Eastern time, for another great day of interactive sessions, including a morning welcome. And then there's going to be several short talks with NSF leaders. There's also going to be a gallery walk, which if you haven't already, you can go through SwapCard now to look at some of the posters that are there, think about what you might want to attend and sign up. And then the last thing is that there's an optional after hours gathering in Wonder, so like a networking event that will start at 6:30 p.m. Eastern time and 3:30 p.m. Pacific time. And that's just going to be for an hour and a half, and it's informal, so you can drop by, say hi to other participants, maybe meet some new people. And it's a little different than Zoom or SwapCard, but fun to check out. So we encourage you to try to make it. But if you can't make it, don't worry, we'll see you hopefully tomorrow for those sessions. And just one final thank you to our presenters for sharing their expertise with us. Presenters, I don't know if you would like to drop your email in the chat, maybe if anyone does have any follow-up questions for you later on, but otherwise enjoy the rest of your afternoons or evenings, depending where you are. And thank you all so much.